This is section 13.5, and you should have watched two different videos prior to this video that kind of went over both curl and divergence and the idea behind them. And in the videos, there are some nice visuals that I think maybe help understand it a little bit better. So what we're going to do is we're just going to talk about the formula for curl, and then we'll do some examples of how to actually calculate curl. So in your notes, you can see that that if you have a vector f that is made up of components p, q, and r, curl f is the following formula. So pretty large, ugly formula here. One of the ways that we can actually remember this formula a little bit more effectively is to start with our vector made up of partial derivatives. So the partial with respect to x, with respect to y, and then with respect to z. And then we have our vector f, which is p, q, and r. And if we were to cross these two different vectors, we have our unit vectors I, j, and then k. And then we have our partial derivative operators, and then we have p, q, and then r. And so then what we get here is the partial derivative of r with respect to y minus the partial of q with respect to z times vector I minus the partial of r with respect to x minus the partial of p with respect to z times vector j, and then plus the partial derivative of r with respect to x minus the partial of p with respect to y times vector k. And if you were to look at that middle term and distribute the negative, you end up getting this entire formula. So really all this is, just to have an easier way of remembering it, is that curl of f is really just the cross product between these two vectors, and in return, remember, we get a vector. So the cross product produces a vector, and that's where curl is going to come from. In the next video, we will tackle our first example.